Okay, so where are we going with this? What are the goals of our freshman organic chemistry? In fact, if you click that in your PowerPoint, you'll get taken to that site, but it's right on the website. You'll see it anyhow. First is to learn the crucial facts and vocabulary of organic chemistry. After all, that's what we think we're here for. And to develop a theoretical intuition about how bonding works. This is the goal the primary goal of the first half of the fall semester, is to learn how bonding works really, right? And that relates then to molecular structure and also how bonding changes. And that, of course, is reactivity. But under the line, there are a lot of other things that we do in freshman organic chemistry that are arguably just as important, like make the scientific transition from school to university. In school, they try to teach you what people know. In the university, you try to develop new knowledge. So you need a different mindset for that. And we hope this course helps you develop that. So learn from organic chemistry, which is really, in my view, a model science, how to be a creative scientist. So here's a creative scientist by anybody's measure, Louis Pasteur. And in the 1880s, he said this in French, but in English it says, knowing to be astonished by something is the mind's first step toward discovery. Another way of putting that is that the characteristic comment on making a real discovery is not eureka, it's, huh, that's funny. Right? So that's what you really have to learn. You learn enough about how chemistry works and form this picture in your mind that when something happens that doesn't fit, you know to be astonished so that you can discover something. That's exactly what Pasteur did, and we'll talk about that in the course. And even perhaps more important, to develop good taste so that you can distinguish sense from nonsense. There's certainly more nonsense floating around than sense. And being able to tell the difference is important. The way you do it is to develop good taste by looking at a lot of good examples, and then you're aware of how crummy the bad examples are. So we're going to try to emphasize good examples and have fun. Okay. So, and as we go along here, if you have questions, break in. You'll do this much more as we go along, I know. So, the class really is mostly about theory, although we describe the basis for the theory and spend a lot of time trying to make it real. But we require Chemistry 126L, the lab. This is the only chemistry course that requires you to take a lab simultaneously. So I hope you're all enrolling in that, because there'll be a certain day that you want to be able to take it. It's just one afternoon a week, 3 hours or whatever it is. But you want to get your first choice, so line up soon. Well, you'll be accommodated, but it's just more convenient if you get it arranged earlier. But why? Because lab answers the really big question. And the big question was brought home to me by my son, John McBride, in his third year. This was the beginning of the third year, and his mother and I didn't know what was coming. For the next year, maybe 15, maybe 20 times a day, he said, how do you know? Right? So here's John this last summer. He's now 38, and he has his own 3-year-olds to say that to him. And he doesn't say, how do you know anymore? He now says, how do you know? Okay? But that is the main question. How do you know what these things that they told you in school? Well, there are 4 ways we could talk about of knowing. And 2 of them are shown on this manuscript from the Carolingian book painter. If we zoom in on the top frame, here's Moses on Mount Sinai. So the first way of knowing is divine authority. Here, he's going to be he's the graduate student here getting the word. Here's a teaching assistant over on the left, perhaps, Aaron, right? And then he comes down from Sinai, right, to see the class, children of Israel, right? So here's another kind of authority, right, which is human authority, interpreting the scriptures. And here you can see the class, and the guys going like, right? And the teaching assistant is off in the side still, right? But this doesn't make it. Science is not faith-based. right? That may be other ways, there may be other things you know that way, but not science, okay? Science ignores divine authority and it ignores human authority. Not that they might not exist, but they don't relate to science, okay? Now, as you walked in today, did you notice these things over here? There's an honor roll of chemists, and in fact, we'll use that a lot this semester. And in particular, one of the people on there is Michael Faraday, who started in a very humble way. He was a bookbinder's apprentice. And he bound this book, not this particular copy, but this book, which is called Conversations on Chemistry. He bound the first edition. This one is a later edition. So you see, it's Conversations on Chemistry, in which elements of that science are familiarly explained and illustrated by experiments. And who's the author? J.L. Comstock. He is actually not the author, he's the guy who stole it. Okay? He stole it from a woman, Mrs. Marcet, in England, who wrote this book, which was the most popular textbook. It was written for girls, but it was the most popular textbook in all chemistry for the first half of the 19th century. It went through like 20-some editions. And here you see at the beginning, it's a dialogue, a conversation between Mrs. B and Caroline and Emily. And it's fun to see this here, what Emily says at the beginning. To confess the truth, Mrs. B, I'm not disposed to form a very favorable idea of chemistry, nor do I expect to derive much entertainment from it. But in the long run, as you can imagine, they have a lot of fun with chemistry. It was a wonderful book, and still is. But he was binding it and read it. And look what he says about this as his introduction to be the leading experimental scientist of the 19th century. Do not suppose I was a very deep thinker or was marked as a precocious person. I was a very lively, imaginative person and could believe in the Arabian Nights as easily as the encyclopedia. But facts were important to me and saved me. I could trust to fact and always cross-examined an assertion. So when I questioned Mrs. Marcet's book by such little experiments as I could find means to perform, and found it true to the facts as I could understand them, I felt I had got hold of an anchor in chemical knowledge and clung fast to it.